In this experiment, I'm going to be measuring the effect that temperature has on the bounce height of a ball. My hypothesis is that a hotter ball will bounce higher than a colder ball because the air inside the ball will expand when it's heated. Balls with more air pressure bounce higher. Also, the heat will make the rubber more elastic, which will cause the ball to bounce higher and have more energy. The variables in this experiment are the temperature of the ball for the independent variable. This is what I'm changing on purpose. The dependent variable is the bounce height of the ball. That's what I'm going to be measuring. The control variables are the type of ball, the tabletop that I'm dropping it on, and the drop height of the ball. Each ball will be dropped from approximately 120 centimeters. Now, one of the challenges of controlling variables in an experiment like this is determining how high a ball bounces. You kind of have to catch the ball at the top of the bounce. So my proficiency as a catcher is a human factor, which needs to be factored out of the experiment. So I'm going to be bouncing each ball at different temperatures 5 times. Hopefully, by bouncing them 5 times, I'll get a more accurate measurement by taking the average bounce height of 5 bounces versus just bouncing them once or twice. The materials in this experiment are 3 racquetballs, a meter stick, 3 1-liter containers, ice water, room temperature water, hot water, and an electrical kettle or pot for heating the water. The procedures for my experiment are to fill the 3 containers with cold, room temperature, and hot water. I'm going to place 1 ball in each container. Then I'm going to drop each ball from 1 meter, or it was actually 1 meter and 20 centimeters. I'm going to measure the bounce height of each ball, and then I'm going to repeat 5 more times for each temperature. The procedures in this experiment are to fill 3 containers of the same size with cold, room temperature water and hot water. I want to use about the same amount of water in each container to control for variables. I'll place 1 type of ball, 1 racquetball in each container, so I'm using the same kind of ball each time. I'm going to drop each ball from the same height, about 120 centimeters. I'm going to measure the bounce height of each ball each time I bounce it, and I'm going to repeat the procedure 5 times for each temperature.
I have 3 containers for water, 1 with ice in it. Container number 2 has room temperature water, so it feels the same temperature as the room, so about 65 degrees. And container number 3 has warm water in it that I've heated to 160 degrees Fahrenheit. So I'm going to place the 3 racquetballs in the water containers. Okay, I created myself a data chart that I'm going to use to record the results as I'm doing the experiment. We're going to start with the ball that's in hot water. They've been sitting in the water for about 5 minutes now. I will hold the ball at the top. I'm going to release it, and it looks like it landed here at 82 centimeters. So drop number 1, 82. Okay, I completed my investigation by dropping each ball 5 times from the same height and measuring how high each ball bounced. I did it 5 times for hot water, 5 times for room temperature water, 5 times for cold water. This is my data chart to show you that I recorded each bounce height for each of the 5 trials.
So I took my raw data chart that I hand wrote and I copied it over onto this chart to make it look neater. And as you can see, I have 5 bounce heights for each ball and an average bounce height. I have labeled on the first column the temperature of the water: hot, approximately 160 degrees Fahrenheit; warm, which was approximately 65 degrees Fahrenheit; and cold, which was 32 degrees Fahrenheit. You can see that I calculated the average bounce height for each temperature. Cold water had an average bounce height of 74 centimeters. Warm water had an average bounce height of 86.2, and hot water had a bounce height of 86.8. So this chart shows the data in a graph form, graphing the average bounce height. There was not a lot of difference between the hot water and the warm water, but when I made the ball cold, when I dropped the temperature of the ball down to 32 degrees Fahrenheit, it had a significant decrease in the bounce height. My conclusion is that my hypothesis was correct. A hot or warmer ball does bounce the highest. There was not a significant difference between the bounce height of the hot ball and the warm ball. The average bounce height for the hot ball was 86.8 centimeters. The warm or room temperature ball bounced an average of 86.2 centimeters, and the cold ball bounced an average of 74 centimeters. The bounce height of a ball is directly related to the amount of energy lost when the ball bounces off a surface. The higher a ball bounces, the less energy that is lost in the bounce. If you're going to the gym to play racquetball in the wintertime, I don't recommend keeping the racquetballs in your cold car if you want them to bounce higher and have more energy.